If we could travel at 99.9% the speed of light, it would take 4 years to get to Alpha Centauri. Would the people in the spaceship feel like they were stuck on board for 4 years, or would it feel shorter for them? You should read The Forever War. It's a novel set throughout our future, and a lot of it deals with the consequences of such fast space travel. You follow a character who ends up experiencing many eras of humanity in the universe over time, as each time they reach their destination it's been so many years for humanity that things are drastically different from when and why they set out. For people in the ship it would seem that they got to their destination almost instantly, because the more you approach the speed of light, the more time approaches a zero value, t equals 0, which would mean zero time has passed. For people observing from Earth it would look like the trip lasted for 4 years. So if I got into a spaceship and flew at nearly light speed in circles around the Earth, it would take only a few minutes for me, but it would be years for those on Earth? Can this be used to effectively time travel into the future? I could take off, fly around for 10 minutes, and when I land, 100 could have passed? If you were to travel at 0.707-ish the speed of light, from your point of view it would only take 1 year to travel 1 light year. Or 4.3 years to travel the 4.3 light years to Alpha Centauri. An observer would record that the journey took longer than that, however. The speed 0.707-ish is in fact the square root of 1/2. So this thought just came into my mind. Let's say there was a constant live radio feed that didn't stop playing that was being transmitted to the ship from Earth. I take it to the occupants on board the ship would hear the radio transmission slow down in speed the faster the ship got? An interesting way of seeing this is if you travel to Alpha Centauri at light speed without acceleration and deceleration at all, you will feel it only takes an instant for you, while other people on Earth waited for 4 years. Does that mean photons never age since they always travel at speed of light? If you had a ship capable of constant 1 gram acceleration, you could get to the Andromeda Galaxy in just 28 years, including deceleration, so that when you get there you'll be stationary. You could do a round trip to Andromeda and back, a 5 million light year trip all up, in a single human lifetime. Of course, 5 million years will have passed on Earth, even though you'll have aged less than 60. Time dilation is a thing. Assuming it's a round trip, it wouldn't feel like 4 years each way. They'd probably just return to Earth and notice that everyone else they know has aged while they were gone. It's a good way to HODL your cryptocurrency, though. Aren't we all traveling at undefined speed at all times? Earth spins, solar system spins, so in a way we are all time traveling. But what about vibrational speed? Could we put someone on a pad like a massage chair but have super small vibrations that get them to travel near the speed of light and therefore time travel?